The next example has some practice on playing with arrays. For instance, when you have one bigger array and you need to split it into smaller ones with respect to some conditions. And the technical side of it is that you may need to use loops and conditional statements, or you may use logical indexing. So we will solve this one using both. And the idea here is that we have a list of BMI indices of 10 people in one array, and we would like to create 3 new arrays where we are assigning values depending on whether somebody is underweight, normal weight, or overweight, and we are given those BMI limits that are used to exactly define which case we are looking at. So let's start with defining our array. Let's call it BMI, and we should get those 10 values. 28, 29.5, 17, 29.6, 25.1, 16.5, 19.4, 23.7, 30.3, and 30.4. All right. And so let's do first the logical indexing. That one is usually really preferred because the code is much more neat. Something that you need to do in a loop, you can actually write in one line. Or in here 3 lines, since we are defining 3 arrays. But it is also faster than loops. So the advantage is that once again, in some tasks where you may have very big data matrix, if you have to do something where you are accessing only a range of that matrix for some reason, it is much faster when using logical indexing rather than writing a loop which will visit a million of rows, for instance. All right, so the task was to create 3 arrays. With respect to the limits, I will define my upper limit, lower limit, upper limit. Let's call it low was 18.5 and high was 24.9. Okay, so what I want to do is to have 3 arrays. The first of them will be underweight, and those will be the people with BMI indices below lower limit. So in order to find those, the simplest way is to just ask BMI less than low, so less the lower limit. And of course, this kind of expression would only tell us yes, no for all the people on the list. So we have 2 of them which are yes, but we don't want this kind of answer. We want to actually see those BMI indices in this underweight array. So what I do is I pick from BMI array, I take my BMI less than low indices. So these are the logical indices, which means that now Matlab will ignore the ones which have zeros and will only pick respective ones in here. So when I run underweight, now I get 17 and 16.5. This is indeed below, both are below 18.5. Now in similar way, I want to get the normal. So now my condition is that we're actually between low and high. So my BMI, remember that you cannot write just like this, low BMI and less than high. When we have combined comparison, you have to separate it with an and then write it like this. So it is like, if you remember from primary school, when we were looking at sets of numbers and you have some maybe A and B, and you want to find numbers which are between A and B, so we would do this kind of picture and look at those conditions separately. So the numbers which are, let's say that we talk about X, which is greater than A, but it is less than B. It means that we have to take the joint or the cross section of two ranges, X greater than A, and, or then in Matlab language it's like this, X less than B. Less than B. Okay, so this is exactly the way how we write it in here. BMI greater than low and BMI less than high. And those ones, if we look at the task, they're actually supposed to be included. So if somebody is exactly 18.5, he also belongs to the normal, and same, less or equal high. Okay, so once again, this is the logical index or logical output. But what we want to have is actually, so now we can see that there are only 2 people with normal weight in the group, but we want to see the weights. So again, from my array BMI, I pick up those which are true for this case. So now this one will produce the values 19.4, 23.7. They are indeed between those limits. And overweight, without much talking, it means it's those BMI values where BMI is greater than high. And indeed, this is the biggest group of also 6. We had 2 underweight, 2 normal, 6 overweight. That adds up to 10. So this is the best way to do it, using logical indexing and not even using find function here on top of the conditions. We would use function find if the question would be, for instance, tell us which one on the list, which one in order, which ones on the list are the ones, for instance, who are overweight or are underweight, and so on. But when you're just asking for values, then you don't need find at all. But yes, alternatively, with a loop, this was with logical indexing. So how do we do it with a loop? If we have one big array and we have to split it into smaller ones with respect to some condition, we don't know in advance how many pieces belonging to each array are in that big one. So this is where we need that trick of first defining empty arrays, and then based on possible true conditions, we will keep adding them. So I will call them, I'll use some shorter names, maybe capital U will be those underweight, and initially we don't have any. N will be the normal ones, and O will be the overweight. And now what happens is that we need to visit everyone on that list. So we will need a loop that will have an index that is going through our elements from the first one until the last one. Now, how many we have on the list? We have as many as our initial array is long. The array was called BMI. So I will say for I, for instance, changing from 1 to length of my BMI array, because I want to make sure that I am visiting every position on the list. Okay, and then what happens? the assignment to specific arrays has to happen based on a check in which range we are. So we will need some if-else statement in here, and actually if-else. So if that ith patient's BMI, the one that currently the for loop is looking at, if his BMI is below the lower limit, then I know I should assign this guy to my underweight array. And again, that means I update my underweight array by saying that it should have what it was before already, and that one extra BMI, which I just found, is fitting my condition. And with a space or comma between if we want to arrange them in a row. Then we have the second range, so the one between. So it means now I have to say that if that particular person's BMI, so the ith person's BMI, is greater or equal low, and at the same time that same BMI is less or equal high, then I know that I should assign him to the normal array, and that assignment is done in the same way as the underweight. So I update my normal array, I say that we should use the same value, all the values that have been collected in there already, and that one extra which seems to be satisfying our condition. And then we are left with the overweight. So with the cases where our BMI is higher than the high limit, so I could write it explicitly as else if as well, but I also know that that case means every other case than what I have mentioned already. So it is enough to say just else, and in here points that we are updating the overweight array. So it's overweight collected so far, and our BMI of that particular person. Now I need to end my if, and I need to end the loop. So remember, everything, every construct that requires an end has its own needs its own individual end. Okay, so now when I run it, I should get my UN and O same as my previously found underweight, normal weight, and overweight arrays. Let's run it and let's make a quick check here. So I will check underweight, and I'm asking Matlab, is it equal to U? If it's equal, first of all, they should end up being same size. If they are not, I will get an error. If they are, and if things are done correctly, I should get all ones from this. All two, if you remember, there were two underweight people, and yes, both have the same, these are the same values that came from the two arrays. Then I will check my normal weights and compare it with my N array. So once again, they should be same length if I have done everything correctly, and they should be all true. And it's just a formality to check the overweight and ask, do they equal? Yes, all 6 people on the list have the same values. And then the task said also that then using an appropriate Matlab function sorts each of these 3 arrays in descending order. Using appropriate Matlab function, which gives us a hint that it's a good time to visit help. And we want to sort something, so why not just put sort as keyword? And usually the top hit or close to it is the thing we are looking for. Sort array elements, we are working with arrays. And there is obviously a few ways to call it. And then for each of these, there is a description. So let's see, if we just put sort A sorts elements of A in ascending order. Now the task said it should be in descending order. So we might need to find some extra parameter for it. Sorts A_dim returns sorted elements along dimension. So this would mean that if our array is not just a vector, but maybe a matrix with 2 or 3 or more dimensions, then the sorting can be done along a specific dimension. That's not the case we are looking for. Then we have direction. So return sorted elements of A in the order specified by direction using any of the previous syntaxes. So ascend indicates ascending order, default, and descend indicates descending order. So this sounds like what we need. If we are not sure yet how to type it, we can look for example here. There should be one. Yes. So how to write it? Well, sort, then give the array name, and then in the quotes, as a name of the option, we put descend. So let's do that. So I either one of those are okay. So I will call it SU as sorted underweight will be sort U descend, and then faster with copy pasting. We also have the normal and overweight, and we create respectively sorted normal and sorted overweight. When we run this part, there we are. So now these are descending order, this is descending order, and these ones also look correct in descending order.